All right, now we're on the Housing Starts Unemployment tab, and our main question here in A1 is, do housing starts predict unemployment, or vice versa, or both? Housing starts is how many new homes were started in the US in any particular month. And we're going to take a naive approach to it at first, which seems to make sense, but then we'll see some issues with it later. The data table starts in cell A50 because for the way we're going to be kind of hacking together what we want to do in Excel, we need a lot of blank room above the table. Something like an ACF table starts in cell G10, and we'll talk more about that in a sec. And the data source information starts in cell T1. So let's scroll down to A50. That's the observation date. So we're starting in January 1959, then February 1959, etc. All the way up through 2020, December of 2020. And column B is the housing starts. So it starts off with 1,600 housing starts in January of 1959. That number might actually be in millions, I'm not sure. We want to check that, but it doesn't particularly matter for us right now. And then in column C is the unemployment rate, so a 6 would be 6%. And then columns D and E we might fill in later. So what would be your first approach to say, can I use housing starts to predict unemployment or vice versa? Well, you might just plot them against each other, or you might plot the data series as a whole. So we could highlight columns A, B, and C starting in A50 and plot that. I'll stretch out the graph here. So we're seeing the housing starts, which are numbers like 1,500 or so, totally dominates the graph of unemployment because unemployment is numbers like 6 and 5 and 4. So unemployment looks like just a plain old flat line. So what can we do to fix that? We can right click on one of the data series and say format data series, and in the dialog that comes up, plot series on, you can say secondary axis, and then close that. And so now the unemployment is plotted on the y-axis on the right, and the housing starts is plotted on the y-axis on the left. You should actually, some people say you should never do this, basically, because it can give the impression of causation between the two series. Like if one thing goes up, the other one goes down. And it's very true, it can accidentally give that impression, so you should hardly ever do that. But this is a controlled classroom environment, and it's important for us to be able to see these two things against each other, because that's kind of what we're looking for, right? So trust me, I'm a professional, but be very careful in doing this with the general public. Now we can see the unemployment tends to go up quickly and then take a while to come back down. So it goes up quickly again. That's, a recession starting, and then the unemployment slowly comes back down as the recession gets resolved. And can you see any patterns like is unemployment tends to be low when housing starts are high, and vice versa? That would kind of make sense. If there's high unemployment, then maybe home builders are saying we're not going to have much demand for houses, so we're not going to start very many houses. You kind of expect that. We can plot housing starts and unemployment against each other the usual way. So I'm just plotting B50 and C50 all the way down the data series, and we use a scatter plot. When you have a data series with X values and Y values, but it's definitely happening in time, that's when I would recommend using connectors along with your markers. So let's give ourselves some layout here. So the x-axis here is housing starts, and the y-axis is unemployment. And can we predict one from the other? It's just kind of a big ball of points. The connectors that show us kind of the time sequence seem to be just kind of going around and around. Let's add a trend line. You just never know. We have no evidence of nonlinearity, so I'll just go with linear. We'll display the equation in the r squared. Get another color that we can see. All right. So the r squared is 0.111, which is not great, right? I'm going to move this graph up to the top. and paste it here or so. You can kind of predict unemployment from housing starts, but not all that well. So take a second, think about how economies tend to work and unemployment and builders planning things. What could we do to maybe get better predictions or even predictions into the future? Because right now we're saying, can I predict unemployment this month based on housing starts this month? But maybe you want to predict unemployment next month. So what we can do, if I click on the data set here and it highlights the housing starts and unemployment that it's getting the data from, and notice here I clicked on the data set, not just on a blank area of the graph. That's an Excel interface thing. I'm going to grab the highlight box that's around unemployment by the edge and drag it down by 1. And that says let's use housing starts from the first row of the data and unemployment from the second row of the data. So that's like saying, can we predict unemployment this month from housing starts last month? And we actually see an R-squared of 0.12 instead of 0.11 like we did before. We can try it at another, like a 2-month lag, and now R-squared is even higher, it's 0.13. We can try it at a 3-month lag, and we can try, we can keep going, right? So we could do all these graphs, but what we could do to summarize all that is just compute the correlation at all these different lags between housing starts and unemployment, and we'll call that the cross-correlation function rather than the auto-correlation function because it's across from one series to the other. So I'll show how to do that in the next video.